Hello, I am Smita Kadam from ENTC department, I2IT, Pune. Let us learn today the working of IC LM317 voltage regulator IC. Before coming actually to the regulators, let us start with the power supply. Power supply is one of the important part of any electronic devices or the project or the small modules that we are using. This power source is available in AC form, then it will be converted into the DC sources using the rectifier circuits. After rectifiers, we will be using the filter circuits with proper capacitor elements, then filtered output will be given to the regulator circuits. Now what is the role of regulator circuit? Regulator circuit is going to give us the constant DC output voltage, required constant DC output voltage as per the requirement of our designed circuitry. Now the regulator circuits can be designed with the help of the discrete components, or these are also available in the form of the ready-made ICs also. So regulator circuits designed with the discrete components may be studied in the form of the series voltage regulators and shunt voltage regulators that are designed with the discrete components like Zener diodes, resistor, transistor and their various combinations. Then comes the regulator ICs, regulators that are designed using the ICs. Now majorly what is the difference between the IC voltage regulators and the regulators designed with the discrete components? External working of both the regulators is the same, internal circuitry may vary. IC regulator circuits, in the internal circuitry they are provided with the features like short circuit current limiting circuit, voltage overload protection circuit, and now specifically talking about the IC LM317. The important features of these ICs are, it is going to source us the current above the 1.5 amperes of current over the output voltage range of 1.25 volts to 37 of volts. Now this is the one of the example of the adjustable voltage regulator IC. Now there are also ICs which are available that is going to give us the fixed voltage regulator output. So let us take the example of the series of 7800 ICs. 7800 ICs gives us constant DC, positive DC voltage at the output in the range from 5 volts to plus 24 volts, 7805 to 7824. Similarly, ICs in the range 7900 can give us the output voltages which are the negative voltages at the output from minus 5 volts to minus of 24 volts. But these ICs voltage regulators are called as a fixed voltage regulators. In case the requirement of the circuit is that at the output we want continuously changing constant output voltage. Let us take 5 volts, then 6 volts, 7 volts, or take the simple example, we want to control the speed control of the fan. So in that case constantly varying output voltage is required, or in various applications the adjustable output voltage is the requirement of the circuit. So in that case we need to come towards the one of the example of the ICs of the switching voltage regulators is IC LM317. It has the 3 terminals, pin number 1, 2, 3. Pin number 1 is the adjustment terminal IC, terminal of the IC, output terminal and the input terminal. Now this is the simple standard circuitry that we can use when we want to use the IC as a adjustable voltage regulator. LM317, the input will be provided between the input terminal with respect to ground. This is the output terminal, and the pin number 1 which is the adjustment terminal. Now this IC provides us some reference values which are constant, that is I adjustment current which is of the 100 microamperes in the range, and V reference voltage between the resistance R1 and the output terminal. So voltage across the resistor R1, it is called as a V reference voltage, and it is in the with the value of the 1.25 volts. Now what will be the output voltage that we will be getting? That is given by the standard formula. V0 is given by V reference into 1 plus R2 by R1 plus adjustment current into the R2 resistance value. Now using this circuit, how we can obtain the varying output voltage through the output terminal with respect to ground terminal? It is possible with the help of the combination of two resistors R1 and R2. R1 is fixed if it is of the value 240 ohms, and R2 is the variable resistance which is we call it as a 10 kilo ohm pot. Then by varying this value we can get the adjustable output voltage. Now the range of output voltage which we can get at the output is 1.25 volts to 37 of volts. So initially we need to design the circuit as per the requirements of the output voltage. We can design the circuit to get the constant 5 volt as output, 6 volt, 10 volts or the 11.5, 12 volts, etc. Now here after this I will be explaining with the breadboard implementation the circuit that is designed to get the constant output voltage of 11.5 volts. Later on, by keeping the R1 constant and by varying the values of R2, we can get the variations in the output voltage that will be observed onto the breadboard implementation. Thank you.